It isn't solely about visually touching our Earth lightly, but our foresight to choose the materials, construction techniques, and innovating to reduce environmental footprint throughout its life cycle. Hence, we aim to deliver a project that encompasses touching the Earth lightly from a visual, environmental, as well as experiential perspective, trying our best to preserve the small environmental nuances that makes Coney, Coney. Now, without any further ado, let us have Shaif showcase our video.
This is our co-working office, sitting at the tip of Coney Island, surrounded in lush greenery. These are a few pictures we took at Coney Island depicting the key features, activities, flora, and fauna. Through in-depth survey, we gained valuable data that shaped our office, and therefore, these are some of the design sketches that we actually did, and this actually shaped our final design. We designed our building such that the heat gain is minimized. The predominant wind direction is from north, northeast, and south direction. And this is the solar steel we implemented as a green feature. We also implemented solar panels. Now let me take you through of our office. As you enter the office, the greenery does not stop at the entrance, but it extends into the office. The lobby is located beneath the undulating slab that creates volumes of varying spatial qualities. As you walk through the lobby, the light door punctures the ceiling, permeating light into the spaces below. And we wanted to blend in with nature, so we actually made columns that actually mimic the branches of trees, and greenery widely extended on the rooftop. The cafe and library is also located on the green slab, and it is surrounded by lush greenery, creating an ideal atmosphere for reading and relaxing. This is our co-working office, and the space does not just remain within the office, but it expands outwards into the open setting, creating varying atmospheres for people to work. This is our section of our building, and this is the green undulating slab with the columns. This is our typical floor plan. We use parametric to actually design the floor slab, and this is the scripting we use. This is a detail of the movable sliding modules that we use. And this is the layering of concrete when we 3D print our models. And this is the construction sequence. For the interior design, especially for the lobby, we wanted to create a tranquil space that is ideal for collaboration. And the library, the reading does not just stop within the four walls, but it expands outward into the green slab. And the office is actually an ideal space for collaboration, and the open spaces provide an alternative atmosphere for people to work and play. Now I'd like to pass my time over to April to explain about the concept.
The green slab we have created has undulations which is achieved through parametric computation design and tapers into the ground where visitors could walk up to approach the waterfront. We have also created voids on the slab to allow for taller trees to peek through and to allow daylight to enter the interior spaces at the first story. Aiming to retain the sensory experience of the current visitors of Coney Island, trees are planted on the slab to form a canopy, replacing the original landscape and ensuring an unobstructed sea view for the visitors. The idea of mimicking the forest is further expressed by having tree-like columns surrounding the library and on the undulating slab. The three larger main modules above the slab are arranged to bring visitors towards the different unique views of the surrounding sea views and flora, which are further disaggregated into smaller modules. Designing our office spaces in modules allows our structures to visually appear as being nested within branches of trees, akin to structures designed by Glenn Murcutt's ethos of touching the earth lightly. Climatic parameters have also allowed us to come up with configuration which allows daylight and natural ventilation to be maximized in each individual module. Right now, I'll be passing the time to Ting Si, who will be talking about the spatial zoning.
Thank you, April. I will be moving you guys through the zoning study that we did. Firstly, the program of the building are categorized into public, semi-public, and private zone. So basically, the first floor will be semi-public, followed by public and private zone at higher level. Auditorium, workshop, and exhibition space are designated at the first floor, below the undulating slab. These spaces are moving forward near to the sea, so as it can capture as much view as we could. We tried to preserve the site landscape appearance at second story with trees and terrain. A library and cafe is nestled within the forest. Finally, for the upper floor, the private offices, co-working areas, and hot desking space, as well as printing facility, are designated at higher story, which will only be accessible to individuals who rent the space. This segregation will help to reduce the impacts of passerby around the office to maintain the peacefulness and quietness of the office. Meeting rooms are mainly located at level 4 to ensure a more conducive environment for discussion. The bigger meeting rooms are designed to be movable, as millennials are subscribed to ever-changing trends. By having a movable platform that slides laterally, it gives one opportunity to move in and out the space that they are in. For example, in the morning, when one seeks for more privacy, the platform will be shifted to the middle as it is the most secluded area of others. Likewise, when it is at night, both modules can be shifted out to the most exposed area in relation to the topic touching the earth lightly. We hope by doing so, it brings forth closer to nature, not only at the ground, as well as above too. Private offices are located at higher story to provide privacy. We have designated the rooftop of modules for outdoor hot desking and co-working, weaving flora through the infrastructure of the building, through pockets of greenery, so that the user can gather to work in nature with nature. Right now, I would like to pass my time to Key, who will be presenting Keen and Sustainability.
So for the manufacturing of the modules, we propose 3D printing with quick drying cements for the PVC instead of traditional concrete casting. This could potentially help firms build the prefabricated units about 50% more quickly and 30% lighter than current prefabricated units. At the same time, this will also mean a reduction in labor costs as well as less waste produced in the production process. To determine the type of environment the building will be in, we have conducted thermal and humidity analysis, sun path analysis, radiation analysis, as well as wind flow analysis using Rhino 6.7 and Grasshopper with the Daily plugin. This analysis helps us in understanding human comfort and air handling needs indoor and outdoors. These factors have allowed us to conduct the Green Mark building rating assessments for our building, and we were able to change our design accordingly. For the critical path of the construction process, our recommendation was to use generative design algorithm to find the optimal construction sequence. This means experimenting with the different steps of the construction, such as the position of the crane and the access points to the site, such as roads. This is done by first having the builder create a generative script of the assembly process, and the team experiments with scenarios to optimize the whole sequence. We also reference the buildability score and the Green Mark score as a benchmark when designing our building. aiming for a Green Mark Platinum award. One green aspect of our building will be the implementation of solar stills at the east and west facing facades. Solar stills work by evaporating seawater and condensing them. At the same time, the filtered seawater in the solar stills will be used for watering the plants throughout the entire building. Here is the heat exchange diagram for our solar stills. Inspired by the Sydney Opera House, our innovative seawater cooling system will be adopted because of the proximity of the site to the sea. The chiller system of the building makes use of the seawater's lower temperature to reduce its energy consumption, thus increasing the overall energy efficiency for indoor cooling. Additionally, solar panels will be added on the rooftops of our modules. With a total of 317 units installed, the total energy generated amounts to 174,000 kWh, equating to energy savings and a payback period of 8.36 years. Another innovation that we had was the wave-like structure for our second storage set. Inspired by the surrounding environment of the sea waves, parametric modeling was done to generate the design by using the climate and structural parameters that we have gotten from our earlier analysis. This is an example of the generation script that was used in the design. Moving on to the AR and VR aspects of our build. Design will be conceptualized using VR, and multiple users are able to share the same virtual space, interacting with each other even when they are situated differently geographically in real life. At the same time, changes could be done to the design with minimal risk as the building is digitally recreated. Another part of VR will be visualizing the construction sequence by identifying the choke points on the site as well as hazards for more effective risk management. In the construction phase, AR will be relevant as various construction elements can be placed accurately by viewing the beam model in real time. This is especially important given the complexity of our structure. The AR devices will also help to detect mechanical, electrical, and plumbing clashes sooner. Now I'll pass on my time to Shai.
So what we did for conflict resolution, and also we uploaded our main model into Google Drive as a central model so that it's easier for everyone to collaborate offline. And we regularly sync it to the Google Drive to ensure that the file is synced. And we also have multiple saves so that to ensure our file does not crash as it's not such a stable server. We had multiple difficulties during our project, but we found numerous solutions. For example, we had lack of time since we are from different schools and different faculties, but how we solved it is by using Skype and Miro. Skype is to have a digital face-to-face conversation, and Miro was used as a bot to have digital drawings while still being at home. And we use, when we have differences in opinion, what we try to do is actually understand each other. We talk it out, and we actually try to ideate to find solutions. And since we are from different years as well, some of us are not used to using Revit, and especially the year 2s, we had difficulty as we just started learning Revit. And so to help us further help us, the year 3s actually helped us to learn better the Revit software and actually taught us the tips and tricks to overcome the difficulties. So there are actually 3 key things that we learned. Firstly, sustainable and energy efficiency, where we learn how to actually design a sustainable building using the various features. And we also learn how actually DFME helps to improve the constructability of a building and how this can actually be used in the future. And for integrated digital delivery, we use BIM software to actually learn how to collaborate, and we really find this useful in our future in the working industry. And with that, I'd like to conclude our presentation. Thank you.
First, I have to say, very comprehensive. Very comprehensive. You touch on most of the items. Congratulations, a good job here. But I'd like to open the floor to my fellow judges first. Gentlemen?
Okay, very interesting. Very interesting 3D printing of PPVC. Do you take any reference from any use technology for this?
Currently, there's a research being done by NTU. So they did the 3D printing of the toilet.
Right.
So we thought we could use that. That was something new. So we did it for the modules instead. For the second story is that instead of 3D printing the whole thing, we decided to 3D print the formwork instead. Yeah.
Alright. Because when I see your report, you actually mentioned that you're using fiber reinforcement and you'll be reinforcing the segment using walls, steel bars, and casting. So it's a hybrid system.
This is just the totally. Initially, actually it's both 3D printing with quick drying cement, and we are also thinking of adding the rebars and all while 3D printing itself.
Okay. That's the last one. Since you mentioned that there's no 3D manufacturing facilities here, and with the kind of volume you're creating a lab to do it, will it drive the construction cost very high?
Good morning. We actually do plan to actually construct a mini factory where the auditorium would be. So all the PPPC units will actually be manufactured on site, and it will be actually teared down as the construction progresses. And what will be done is that the huge spanning area will actually convert it into the auditorium, as it has very similar architectural features. In addition, we are only using it for the units on top. So after it's done, what we'll do is we'll pull out the cranes, and then we'll actually construct the remaining part of the berm to cover up the small little gap that we actually left for the PPVC units to be hoisted up.
I think it's a very good use of space, but probably a big thing about cost because the volume and the reputation for this project is actually generally low.
Which comes to my question. How many module types do you have? Okay, that's one question. Okay. Second question that I have is, what is your total constructability? What is your total constructed floor area? Because you mentioned that the entire construction is 19 million. So I just want to have a feel of